In this lecture, we will be discussing Aitken interpolation, or the linear part of it. I just hope you remember how we derived this formula. And if you have not seen the last video, that was my linear Lagrange interpolation, where I elaborated on how to arrive at this formula. So please go through that video. The link is above in the I button. So from here we will continue. This is my determinant. I will use some of the properties of determinant. This is my rho 1, this is my rho 2, and this is my rho 3. So what we do is we'll replace rho 2 by rho 2 minus rho 1, and we will replace this rho 3 by rho 3 minus rho 1. So this will be my new determinant, that is yx1 y1 minus y x1 minus x 0, and this will be y0 minus y x0 minus x and 0 this side, and this will be equal to 0. Moving on further, what we can write as actually the determinant when we calculate with respect to this column, that is my column 3. These two terms are 0. The only term that we will be left with is this one, determinant of these four terms, that is my y1 minus y x1 minus x y0 minus y and this side x0 minus x, and this will be equal to 0. Now we will use some properties of determinant. Now we can rewrite this determinant of mine as y1 x1 minus x y0 x0 minus x and minus this way, and this will be equal to y x1 minus x x0 minus x, and this will be equal to 0. Again we'll use some properties of determinant. So this will be y1 y0 x1 minus x x0 minus x and minus, just what will we do is this is my rho 1, this is my rho 2, so we will replace rho 2 by upon rho 2 minus rho 1. So this term will remain same, y x1 minus x and this y minus y, that is nothing but 0, and this term will be x0 minus x1. Now this is equal to 0. Obviously when we'll find the determinant of this part, this will be y into x0 minus x1 minus 0. So this term will vanish only. So we arrived at y1 y0 x1 minus x x0 minus x minus y into x0 minus x1, this is equal to 0. Or what we can write as y is equal to 1 upon x1 minus x0, and as we have changed this sign, so this two term will interchange, that is this would be y0 x0 minus x and this will be y1, and this term of mines, that will be x1 minus x. So this is my formula for Aitken's linear interpolation. Well, you might be thinking that we derived this formula from Lagrange linear interpolation. So obviously will they be same? That means will we get the same result by utilizing both this formula? Yeah, obviously we will get the same result. So you might be thinking that why we have to read these two different formulas, like first one was our Lagrange and second one is our Aitken. So actually the case is when you move on to higher degree polynomial, then this formula will change. But the method that we derived, that won't change at all. Okay, let me show you an example. See here. So this is my Aitken's polynomial, and this is same as what we derived. This is for degree 1. That is if we are given 2 data points. And if we are given, let's say, 3 data point, then the formula will change, and this will be calculated by utilizing the previous two values of this Aitken interpolation. And similarly, if we move on to more higher degree, we'll utilize the previous value calculated. Okay, so let me show you an example. Suppose we are given an equation, or better say this is my sin x, y is equal to sin x, and for x is equal to 0.1, the corresponding value of sin x, that is given as 0.0983, and for value of x is equal to 0.15, we are given the value 0.14944. So these two are the corresponding value of sine. What we have to do is we have to calculate the value of sin x when x is equal to 0.13. So we will calculate it as sine of 0.13, that is equal to 1 upon 0.15 minus 0.1, and this will be y naught, that is my 0.0983, and x naught minus x, that is 0.1 minus 0.13, and this side 0.14944, and this side 0.15 minus 0.13. So we'll just simply calculate the value of this determinant, obviously using my calculator, and you will find the result as 0.128984. So this was all about Aitken's interpolation. Okay, let me make you show another example here. So consider we are given n plus 1 data point, that is my x naught, y naught, x1, y1, and up to some x and yn. Okay, so actually this is the formula only. What we need to do is, suppose this is my example, that we are given this 4 data point, and we need to evaluate the value of fx at x is equal to 0.25 using my Aitken interpolation technique. So what we'll do is we'll keep on calculating the values of this part, my delta 01, delta 02, delta 03, and these are nothing but my determinants only. How we define them as delta 01, that is 1 upon x1 minus x0. Okay, this is same as my linear part that we have calculated. And how we will calculate the second degree of this, that is 0, 1, 2. This will calculate using delta 01x, like we have replaced this value of y0 with this delta 01 and this value of y1 with delta 02. And similarly we will keep on calculating the values. This is something like divided difference formula, that is we keep on subtracting and dividing, and finally we arrive at a particular result. So this was all about my Aitken's interpolation population formula. Well, you can check the values here, and in the next lecture we'll be discussing the Newton interpolation formula. Thank you so much, stay tuned.